Hello everyone. In this video, we will discuss about the data preparation phase to model the data. First, how to partition the data, Python. We will import the libraries. First, train test split. This library is to split a dataset into the training and testing set. Then we will import the pandas. This library is used for data manipulation and handling, creating a data frame to store a data. Then we will create the data frame that contains the three column. Feature 1, a series of integer from 1 to 10. Feature 2, a series of integer from 11 to 20. And target, a binary target column with values alternating between 0 and 1. Then partition into 80% train and 20% test. Then the train test split function splits the dataset into two parts, one for training and other for testing. The parameter test size is equal to 0.2, indicates that 20% of data will be used as the test set and remaining 80% of data will be as the training set. Random state equal to 42 ensures the reproducibility of the split. If you run this code multiple times with the same random state, the split will always be the same. Now we will print the results. Print train, this is the subset of the data that will be used for training the model, and print test, this is the subset that will be used for testing the model. Now in this case, 80% of data means 8 rows are assigned to the trained data set and 20% of 2 rows are assigned to the test data set. So this is the output. Now moving on to the second, how to build a card decision tree using a Python. So first we will import some libraries. A decision tree classifier used to create a decision tree classifier. Plot tree is a function from sklearn.tree used to visualize the trained decision tree. Load arrays, a function from sklearn.dataset that loads the arrays dataset, which is classic dataset used in machine learning task. Then train test split is a function from a sklearn.model selection used to split data into training and testing sets. Accuracy score, a function from sklearn.metrics used to evaluate the performance of the classifier by computing the predicted labels to the true labels. Matplotlib.pyplot is a plotting library used for visualizing the decision tree. Now we will load the data set. The load arrays function will be used to load the arrays dataset into the variable data. Then the data.data contains the feature data, which is x, which includes the measurements of a different features like sepal length, sepal width, petal length and petal width. And data.target that contains the target labels y, which are the species of the iris flowers. Now splitting the data into the train and test set. The data set is split into the training and test set using the train test split function. Test size is equal to 0.3, means that 30% of data will be used for testing and 70% will be used for training. And random state 42 ensures that the split is reproducible. Running the code multiple times with the same random state will produce the same split. Now create and train the cart decision tree. A decision tree classifier is created with the following parameter. Criterion equal to Gini. Gini index is used as the measure of impurity of the splits. Max depth is equal to 3. The maximum depth of the tree is limited to the 3 to prevent overfitting and create a simpler model. Random state is again equal to 42. Ensures the training process is reproducible. Now predict and evaluation. This predict function makes a prediction on the test set. Accuracy score compares the predicted labels to the true labels and calculate the accuracy of the model. The accuracy is printed to the console. The result indicates how well the model performed on a test set. And plt.figure sets the figure size for the plot, and plot tree function visualize the trained decision tree. It contains the parameter feature names equal to data dot feature names, labels the features on the tree like sepal length, sepal width, and etc. Class names is equal to data dot target names, labels the classes on the tree, and field equal to true colors the nodes based on the majority class in each node. plt.show is used to display the decision tree plot. So after running this code, we get the following output. Have a look on the output. Okay, now moving on to the third, how to build a random forest using Python. So first we will again import the library. Random forest classifier is a class from sklearn.ensemble used to create a random forest classifier. Load arrays is a function from a sklearn.data set that loads the arrays data set. Train test split is a function from sklearn.model selection to split the dataset into the training and test set. Accuracy score and classification report are function from sklearn.metrics to evaluate the performance of model. Then we will import the Panda, that is Python library used for creating a data frame and handling the feature. Now load dataset. Load arrays. We will load the data set using the load arrays function. The dataset contains the four features: sepal length, sepal width, petal length, and petal width, and three classes. Data dot data contains the feature matrix X, and data dot target contains the label Y. Now we will split the data into the training and test set. So the data set is split into the 70% training and 30% testing data. Test size is equal to 0.3, indicates that 30% of the data is used for testing, and random state is equal to 42, ensures that the split is reproducible. That is, you get the same split each time the code is run. Now we will create and train the random forest model using a random forest classifier. N estimators is equal to 100. This is the number of trees in the forest. In this case, the random forest will consist of 100 decision tree. Now max depth equal to 3 means the maximum depth of each individual tree in the forest. Limiting the depth prevents the overfitting and helps in reproducing a simpler model. Random state is equal to 42 is for reproducibility. Now we will use the fit function to train the model using the training data. Now making predictions and evaluating the data. The accuracy score calculates the accuracy of the model by comparing the predicted labels with the true labels. The accuracy is printed with the precisions of 2 decimal places. Now discussing about the feature importance. The feature importance attribute of the trained random forest model is access to get the importance of each feature in the making prediction. A panda's data frame is sorted in descending order based on the importance score to display the most important features at the top. At the last, we will print the feature importance, and after running this code we get the following output. Accuracy is 1.0, classification report that contains the precision, recall, F1 score and support, and feature importance like this.